Hello, this is Rick from MathX, and today we'll be solving number 21 from the 2019 AMC 8. Now, this problem was kind of disappointing because for an AMC 8 Final 5, this problem you can solve as soon as you graph the thing. However, because of its high stature on the test, people probably got intimidated by it. But when you take the time to really look at what this problem is all about, you realize how easy and underwhelming this problem is for a Final 5 problem. So that's what I'll be going over today. Without further ado, let's get straight into the problem. What is the area of a triangle formed by the lines y equals to 5, y equals to 1 plus x, and y equals 1 minus x? So first I'm going to draw my coordinate plane so we can kind of get an idea what this triangle looks like. It doesn't need to be perfect, but it needs to be good enough so we can at least understand what we're doing. So let me quickly do that. Now that we have our axes drawn out, there's two things we could do here. We could either graph the lines individually and then see how they form a triangle, or we could do the superior, much more efficient strategy of just graphing out the vertices of the triangle and then collecting the lines. So I prefer to do the more efficient strategy. So we just need to find out where each of these lines intersect each other to determine the vertices of the triangle. So we just have to pick any two of these lines and see their intersection points. So for line y equals 5 and line y equals to 1 plus x, in order to find out where they overlap, we just have to take y common. So that means that 5 would have to equal to 1 plus x. Well, if 5 equals 1 plus x, simple algebra and just subtracting 1 from both sides would tell us that x is equal to 4. So this intersection between the line y equals 5 and y equals to 1 plus x would give us x is equal to 4. And if x is equal to 4, 4 plus 1 equals to 5. So the first point of intersection would be 4, 5. The next point of intersection is, let's take if we want to find the intersection between lines y equals to 5 and lines y equals to 1 minus x. Well, then we'd have to do the same thing. We put 5 is equal to 1 minus x, because in this case, they both say they're equal to y. If 5 is equal to 1 minus x, well then, we can simply rearrange the terms, bring the x to this side, and we get x is equal to 1 minus 5. Basic computation tells us that that means x is equal to negative 4. And plugging into the equation, we get y is equal to 5. So our second ordered pair is negative 4, 5. Our final ordered pair is where y is equal to 1 plus x and y is equal to 1 minus x. So then, since y is common in both of these cases, we can simply express this as 1 plus x equals to 1 minus x. Now, in this equation, we can bring the x to the other side, getting 2x, and we can bring the 1 to the other side, getting 1 minus 1. Now, 1 minus 1 is 0, so it's 2x is equal to 0. Obviously, by dividing 2 from both sides, we get x is equal to 0. So then, in this equation, we get x is equal to 0, so then we plug it into this equation, we get y is equal to 1 minus 0. 1 minus 0 is 1, so our final vertex is 0, 1. Now, we need to graph out these vertices onto the coordinate plane to see what our triangle looks like. So let's quickly do that. So now, we have the 3 vertices of the triangle. So once we connect the dots, we have the triangle itself. Now, we can find the base and the height of this triangle quite simply. First off, we see that this side of the triangle, the one with vertices of negative 4, 5 and 4, 5, well, they both have the same y component. Well, this means that this line is parallel to the x-axis. That's good to note because the x-axis is perpendicular to the y-axis. So if the x-axis is perpendicular to the y-axis, and the x-axis is also parallel to this line formed by negative 4, 5, and 4, 5, we can say that the y-axis is also perpendicular to the line formed by negative 4, 5, and 4, 5, giving us that the distance between the point 0, 1 and the intersection of the line negative 4, 5, and 4, 5, that would be the height of the triangle, with negative 4, 5 to 4, 5 being the base of the triangle. So to find the area of this triangle, we just have to multiply the distance from negative 4, 5 to 4, 5, and we'd multiply that with the distance from the intersection of the line of negative 4, 5 and 4, 5 with the y-axis. And then we divide that by 2 to find the area of this triangle, because each of these parts makes up the components. So to find the base of this triangle, we just have to find the distance from negative 4, 5 to 4, 5. Well, these both share the same y-axis, so there's nothing we have to worry about there. So we just need to subtract 4 from negative 4. 4 minus negative 4, well, the minus minus would give us a plus, so it comes down to 4 plus 4, which would give us 8. So we get the base of this triangle would be 8. As for the second part, now we know that this triangle has a y component of 5. And it also, the intersection with the y-axis, well, it intersects directly on the y-axis. So that means that it has no x component. The x component of it is 0. So the intersection point between this, the y-axis, and this line is 0, 5. Now, to find the distance, these both have the same x component, so we merely just need to subtract 5 minus 1. Now 5 minus 1 is just 4. So we have the height of the triangle and we have the base of the triangle. Base is 8, height is 4. So to find the area of the triangle, we have to multiply these two and then divide by 2. So you do 8 times 4 over 2. That'll give us 32 over 2, which is 16. So we see that the area of this triangle is 16. This problem was really simple. Once you graph it out on a coordinate plane, you could honestly skip lots of the steps that I went through, because it seems so intuitively there. We know that the area of a triangle is just base times height, and the base and height are so easy to find out. The only real trouble you'll have with this problem is just graphing it in the first place. Because of its high position on the test, there are surely many people who just feared to waste too much time on this problem. But those who did spend time on this problem were greatly rewarded, as they got a free answer with little to no effort, showing how you should not fear the problem before you have attempted it. So, before I'd like to end this video, I'd also like to give a shout out to a channel, Codex. Now, Codex is a great YouTube channel if you want to learn about coding in various different languages. I've checked a couple of their videos, and so far I've learned some great coding in Scratch and other languages. Nonetheless, you should surely check out that channel if you want to pursue more coding. And see you next time for a new math video.